Good morning, sir.
Good morning, everyone. Uh, uh,
म्हणजे हा विषय आधी पुढे घ्यायचा त्याचं काय होणार? समजा हे 50 या महिन्यात 50 समजा यांनी 50 दिली स्टॉक लगेच येणार आहे का? आपल्याला पेमेंट स्टॉक मध्ये आलं.
Good morning, everyone. It's already 11, and we'll just wait for couple of minutes because people are still joining. Okay. Uh, uh, okay. I think we can start with something which is not fully or completely related to the subject today, but it is regarding reactive power, for which we are mainly going to discuss. Reactive power for RE plants, and just the basics before more people join. Maybe we can start with that, and then we'll go to the main topic for today, which is the issues which we are facing for RE integration with the grid. So I'll just open my standard presentation, and maybe we can start with that, because I'll be continuously busy in admitting the people also. They are continuously joining. Okay. Hmm. So I'll just give my brief introduction. Myself, Baldevraj Naran. I'm CEO of Clariant Power System Limited, which is based at Pune, and we give solutions for reactive power and power quality. And we are giving solutions to industries or even infrastructure projects, utilities, and the RE plants also. We have given many solutions. So the today's topic mainly is about the RE plants, but I'll just take you through the general couple of minutes or few slides about the reactive power. So we have a company called Clariant Power System Limited, and we are having collaboration with Fraco of Germany. And then recently we have taken over one of the oldest and the largest plants of capacitor manufacturing, Madhav Capacitors Limited. And this is just I said about the few slides about the reactive power before we go to the main subject. Suppose we have a load of 80 kilowatt and we are running it on the grid and without any support, local support with the of the reactive power. So what we need is we need 80 kilowatt to be imported from the grid and 60 kVAr of the reactive power to be imported from the grid if the power factor of the load is 0.8. So what we have is we are having two components. One is active power and reactive power, and the vector sum is reactive apparent power, which is the billing unit today. So we have to see that we have both economized. The reactive power should be economized to have the optimum billing. So this is an example which gives in more details about the reactive power, maybe imports or whether we can do it from the grid or we have our own installation. So suppose we have a load with original power factor of 0.7, 100 kilowatt load. So at 100 kilowatt, the multiplying factor for reactive power is 1 only. So we need 100 kVAr of reactive power as well. And if we don't have anything, local capacitors or any other unit, active or passive, we will need to import 100 kVAr of reactive power also from the grid. And we'll need to take a sanction of 142 kVA for a load of 100 kilowatt. And now suppose we put a power factor capacitor at the local location and improve the power factor to 0.95, and we are putting a sort of 67 kVAr locally. We need to import now remaining 33 kVAr from the grid, and the sanction, the demand also comes down by 100 to 105 kVA. And these days the target is to get a unity power factor here instead of 0.95, so that we don't import anything and we have the optimum billing. And these days there is another component which is harmonics. I'll just add some more people are coming. So harmonic is also introducing a distortion power factor, and the harmonics have their own reactive power consumption as well. So what we ultimately get is the displacement power factor, which is the two-directional formula, kilowatt by kVA. We have to multiply by this. Yes, sir. Anything? Oh, so we multiply this displacement power factor with distortion power factor, and then we get the true power factor. So this is how we go from the initial to the final power factor. And then the billing, as I said, the reactive power is also the leading power factor these days is also taken into account while calculating the power factor and for calculating the kVAh value, because the leading was creating a problem. The meters used to be locked at unity power factor, and above that everything was considered unity, but that was creating a problem. So that's why the RKVH lead is also measured today, and we get the true KVH value. And this is how the distortion works. This is a third dimension is there. Instead of two-dimensional, we have a distortion, and that has its own reactive power. The power factor also changes. The KVH also changes, and we have the now the billing is likely to go back to the true power factor, and then the distortion due to harmonics will also be taken into account. So this is some few slides about the reactive power. Now let us come back to the main topic of today, which is uh, what we call issues that we are facing in the integration of RE plants with the grid. So recently there have been, I'll just stop sharing these slides. So recently there have been, over a period of last 1 year, many trippings. To be precise, about 28 trippings I read in a document from CA, and they had a span of around 1 year it was happening, and more than 1,000 megawatt is isolated from the grid. RE generation is isolated. And this is happening at maybe some remote locations in Rajasthan, particularly. This was done. So the way out has to be found out, because we cannot live with this. We are increasing our uh, penetration of reactive renewable, and if it is not able to work in a fashion what we want, and there are trippings and isolations like that, the grid interruptions are there, so it is not a sort of a good scenario, and we can't accept it. So the agencies involved in this integration, they had suggested a solution, which was that we should go for a STATCOM for the reactive power, and maybe that will override the problems and the situation could be improved. So that is what we have to discuss today, whether this solution is definitely the STATCOM is a better reactive power mode compared to maybe switched capacitor banks and all. But is it really the solution, or is it going to solve the problem, or we may continue to have the same issue? Have we really studied the issue closely and come to a conclusion that this is the only way out? So that's what we will be discussing today. And I don't have any formal format for the today's meeting. I have just noted some points, and it is an interactive thing. I will be just throwing open the points only. I'll just elaborate the points, and then maybe we can get some opinion from the experts also. And today, one thing which is to be appreciated is that this webinar is organized by CEA. They agreed to organize the webinar, and they, for the first time, agreed that we should have uh, participation from outside agencies also. Normally, these organization, the webinars which are organized by CA, they are only for in-house participation. Only the technical teams of CA participate. But for the first time, they agreed that we will have the participation, broad participation, so that this is a very critical issue, and let there be a wider participation, and let there be some thing coming out of this, if it is possible to have some better alternative or some more opinion, so that we can deliberate on this thing and have a solution maybe which is feasible, or which could be acceptable across the all segments, all the stakeholders also. And I thank CA for giving this opportunity and organizing and allowing the people to participate along with them. So CA teams are also available today, along with maybe Grid India or CTUIL, Central Transmission Utility of India, who are the agencies involved in the grid integration. So, so what I will do is I'll just because what is happening is the grid is now increasingly getting dependent on renewable power, and these plants are coming at maybe far end of the network, and the fault levels are very low, and there the issues are there. Whenever there is a fault, or whenever there is a instability occurring for any reason, the systems are going into maybe their loose synchronism, and the RE generation is lost in that case. So let us deliberate upon this thing. What should be the solution for this thing? Whether we are taking all precautions in the integration, or whether we are lacking somewhere and we are just thinking that a STATCOM could be a wonder drug and it could solve the all issues. So if we go for STATCOM and ultimately suppose we remain at the same situation, that will not be a good scenario. So that is the purpose of webinar today, and we have the experts today who can. In fact, I am, I should give a disclaimer. I am not a power system expert. I just have some collected some, you can say, information. We are giving solutions to renewable power, and we have some knowledge of how these things are, you can say, behaving in the system. And that's why we have some understanding, but we don't have the complete understanding of the system. And maybe experts can elaborate better also once we go forward during the discussions. So let me share one screen where I have noted some only points, where maybe we can just discuss these points and find out if we can have an alternative coming out of these discussions. So, some people are joining, so let me admit. Okay. Okay. So these are some of the points which I have written. Uh, and now, the first is that with more and more conventional coal plants retiring, the fault levels are dropping. And the more and more RE plants these days are being required to come up with grid forming inverters. Today, what we have is normal grid following inverters, and these have limited capability, and they are not able to cope up with the situation, with the instabilities in the system. And that is one of the reasons we have these disturbances, because these inverters are as good as statcoms only, because they can also supply reactive power, and they are in fact supplying reactive power in maybe installations overseas we have seen. And they are able to take up the, you can say, problems head on, and they are able to resolve them, and they are not issues like what we have in India. As we said, we had maybe 28 incidents in a period of 1 year, and our SCR level is maybe between the at the farthest end, even at the remote end, our SCR is still between 5 to 10 or something. And mostly we have a very strong grid. We have 400 kV or even higher voltage networks, and the voltages are stable, the network is strong, the fault strength is good, but still we have the issues. And in Australia, what I was talking to some people there, they have the SCR typically in the range of 3, and maybe it goes in some cases even as low as 1.2. And despite this being the situation, the incidents of RE isolations are very rare. Maybe they had in one region some issues about a year or two back, and they could resolve it just by retuning the inverter controllers. And it was not that they had to go for a very blanket solution like Statcom and all to get the thing. So it was very simple. Just switch off the phone. So they were able to ride through the situation, and they could solve the problem just by retuning. And the situation is normal despite the grid being weak, despite the situation maybe much worse than what we have in India. And what they really concentrate more is on the, you can say, controller tuning. All the gains, the time constants of power plant and inverter, they are well coordinated, and maybe they are able to save the situation without any grid forming even systems, the inverters. They are able to ride through the problem. And maybe the standard controller settings could be sufficient to go through the situation, or to have the situation in control in a strong grid. But in a weak grid, we require a very precise, you can say, tuning. And in most of the inverters there, they are capable of conforming to the SCR level of 2 or 3 also. And I don't know what is the situation in India. That's why I said I'm not an expert. I don't know what we have in India, but this is what I found out that situation there. And maybe the lack of experience or expertise about the grid integration in the renewable plants could be one of the issues. And instead of attacking that, maybe we are jumping to the solutions which are not realistic, maybe like Statcom and all. So this is one thing I wanted to just point out. Then issue may get resolved to a great extent with just a right technical modeling and inverter tuning. The modeling is very, very stringent there. It is one of the toughest in the world today. What they have in Australia, that's why they are able to manage the situation in very, very weak grid conditions without any issues like that we have, even despite having a strong grid and better fault levels and better voltage levels and all. We go to the next page. So they use first of all the inverter as it is. Maybe if we have the proper tuning, proper modeling, maybe any inverter could be good enough. But what they, despite that, also despite having the best tuning, best you can say modeling, they use only high-end inverters. The maximum population there is of SMA inverters. And then there are two more which are common after SMA, that is Ingeteam and power electronics, and others are very, very rare. So this is what one of the you can say reasons could be there, that they are using a good tuning, they are using good modeling, and they are having very, very high end inverters. And if in any current source system we have other inverters, or it is you can say Statcom, they are phase lock loop controllers are there, and these are, suppose they are not able to track the angle changes in a fast changing fault condition. The angle changes could be either too fast or they could be too large, and the inverter is not able to survive if it is the PLL are not able to detect that, and they are not able to trip it also. So either it may trip, or it may go into unstable operation, or it may go into an oscillatory mode behavior, or it can have damped undamped oscillations and all. So the inverter may still remain in the system, but it may not be doing anything. And because the problem is not of the reactive power control or the voltage control, it is basically lying with the maybe inherent capabilities of the inverter. It is not able to track the changes in time and set the things right. Unless there is a protection to sense this instability and trip the inverter, it may just stay there and it may not do anything. Those statcoms or inverters, they don't survive in that weak grid conditions. That is what may be happening with us, and that is could be the reason that we are not able to ride through these fault levels and fault problems. And maybe if we have the better modeling, better tuning, that the problem could be solved with that itself. And what is done is that because these are very grid following systems, and if the situation is really grave, and maybe despite everything we are not able to ride through the problem, then what we need is a synchronous condenser, or maybe a grid forming system like synchronous condenser. And they provide the fault current, they have the rotational mass for the inertia, and they are able to cope up. And these synchronous condensers are coming in a you can say a big way there after the penetration is increasing, and they have a roadmap for 100% penetration of renewable power. Now we have a very maybe small percentage, but even up to 100%, if we have to go, then we have to see these alternative technologies. We cannot depend only on the Statcom or only on the inverters, and maybe save the situation. And there are also some issues, like there could be an interaction, because there are maybe many plants in a particular area location, and these plants, the controls may be interacting with each other. There could be a resonance problem, there could be a control interaction between them, and that could also lead to instability. So all these problems get solved with retuning or proper modeling. So that is what they had, some problems like that, and they were able to manage the situation with these. So now what we have to see is that we develop the network capabilities, and that then only we can unlock the potential of renewable power, and we can have it to exploit fully around maybe a 24-hour time span. Also we can exploit it, and sufficient inertia has to be built into the system, and each sub area or sub network needs to have the maybe meet the applicable inertia requirements, and that is what maybe we are lacking in that also. If we are not able to solve the problem with simple tuning and simple maybe using better inverters or things like that, then we have to go for these things. And the sufficient fault levels have to be maintained at maybe all the nodes, and then only the system strength requirements can be met, and that maybe we are lacking in that also. And still we are better than other people, and we face the problem, so we have to look as an overall picture how we can maybe ride through these issues. And inertia for a system is an inherent physical property, and then the overall system dynamic strength performance, it depends on the inertia. So that is very important that we build the inertia, and this inertia we have many. I'll just come to that also. Maybe we have some other alternatives as well, the modern alternatives, we'll talk of that. Then transient stability, it requires the presence of, and because I'll just say that these points, they are not in any particular order. I have just noted, and I wanted to throw open these points to the audience and see that if we have some better understanding, because I have my own limited knowledge on that thing. But I'm just opening up these points to see that we come out with some better, you can say, points. And the transient stability requires that the synchronizing torque and the damping torque, which is historically provided by the synchronous machines, which are being phased out today. So that is what the problem is coming from. And the proven technologies we have, as I was talking, the synchronous condenser is a proven technology, and that is what is already being adopted at many places. And maybe there is another alternative. The whatever plants, coal plants are being phased out, we can use them only as a synchronous condenser. So that is one of the very cheapest way of doing the things. And the other technology is that we have the newer technologies such as grid forming inverters. We have to have maybe grid forming inverters as we go more and more into deeper penetration of renewable power. And then we will need these grid forming inverters. And this is already happening in places where the penetration is increasing. The new plants are coming with grid forming inverters. We have the batteries. And these batteries, just by their on their own, they are not becoming a grid forming. They have to be configured for that. Then only they become the grid forming. Otherwise, they are just a two-way device only. And then there is another grid forming system is pumped hydro. In fact, all the storage out of all the storage in US, the 93% is pumped hydro. So that is another way of improving the maybe grid strength. I don't know how much we have in India and how much it can be done, or whether it is being done or not. That we have to see. And then batteries, as I said, we can put it with the inverters, or we can put it with even with the statcoms, and we can get that grid forming system. And then the gas generation can be used, and these things can smooth out through the peaks and fill in the gaps from the variable renewable energy, because renewable energy is variable, it is not a constant source, and we have to see that we are able to cope up with the variable nature of this generation also. As I said, the batteries need to be configured for grid forming mode, and then they provide the virtual inertia. Otherwise, they also are not for a grid forming, you can say, item. And when we are relying on the renewable power, which is varying, and it is not a constant source, and then there are technical challenges, and that is what we are discussing today also, how to meet these technical challenges. And the system strength is one of the important things. This has to be maintained to ensure the ability of the power system to maintain a minimum amount of fault level and stable voltage waveform at any given location. And it is required both during steady state and as well as during the disturbed state, or the maybe unstable state. And the grid connectivity process for renewable is very stringent and very complex process. I don't know how complex and stringent way we are treating it in India. But as I said, in Australia, it is a very, very stringent thing. There are experts who do the jobs. They are specialized consultants who handle these projects through various stages till commissioning, and they are doing the modeling, and they are doing the tuning, and they are able to, you can say, get the things to the level which they are today. And entry of a inverter is very, very difficult in Australia. As I said, they have only those three inverters mainly available. Maybe 90% or more are only that population is there. So we have to maintain that quality. Then only maybe it is possible. We may not need anything additional like Statcom. If we have the inverters of proper maybe grade and properly tuned, maybe we may not need anything else. And it is a very long process, this tuning and this grid integration. And there it is very uncertain. You may not get the approval despite all those processes being followed, and you may not be able to meet the grid codes. And the grid code, one of the stringent grid codes they have, and this technical modeling discussions, regulatory agencies with, and with network service provider, all these things are done by these specialized consultants, and then only the things are allowed to be integrated. I don't know how strongly, how seriously we are doing it, and we are able to manage it. Then, so what we basically need is what is the ideal solution? Here the inverters, what we have, we are not using them as intelligent inverter. Maybe the inverters are there, but they are just working as a dumb inverter only, without much intelligence. The ideal solution is we should have a available reactive power, unused reactive power from the inverters, because inverters as it is, they are never run at the full capacity. Maybe a point, they about 80% or so, they are maybe we can say they are available. And a 40 or a 4 MVA inverter, 4 megawatt inverter can give you 2 MVR at that point. So when we see the D curve, it can be found out that maybe we can get that 2 MVR from there. So we have to utilize this capacity is available. We don't need any additional STATCOM. The capacities are available in inverters which are better than STATCOM in many ways, and they can ride through the problem. But if we are not using them properly and we are asking for something special, additional, so it maybe it has to be seriously looked into. And then we can have a hybrid reactive power solution. Hybrid means we can have a besides inverter, we can have switched capacitors, we can have STATCOM, and switched capacitors in any case will be needed for harmonic mitigation, because the requirements, the grid code is very stringent about the harmonics, and some of the harmonics have to be taken care, and most of the places they are found to be available. And in any case, we have to use the switch capacitors, and we have to see that we tune them and we are taking care of the harmonics with those switch banks also. So they cannot be written off completely because of this. And when we are using inverters without any overcapacity, and we are operating at unity power factor, we don't have any reserve capacity available. That's what we have to look into that. There I found that they are operating inverters at 0.93. So there is sufficient reserve available. And when we are here also, we can operate at 0.9 or 0.95. I don't know whether we are doing it or not. I don't have full, you can say, information on that. And during fault condition, the inverter intelligence is that it has to have that mode, whether it can have it can go to Q priority, it can go to P priority when it is the active power is required, and during the unstable condition, it has to go to Q priority. And I don't know whether we are setting, or we may be setting it definitely. So that's what we have to look into, all these things. And another problem what we have seen is, as I said, the inverter tuning is critical, and the power factor, maybe a unity what we are operating, we have to look into that. And here, as the thing which is as simple as night mode operation, we have no activation. I don't know whether it is activated somewhere or not, but we had a client who was suffering because of the overcompensation at night during non-generation hours. The power factor was going to 0.9 or 0.2 leading, and they had a 10-15 kilometer long transmission line. The line had about maybe 1000 kVAR capacitance, and during night they had only the in-house loads of maybe their control room the battery charger or the air conditioning and office loads and all, and it was hardly 60-70 kilowatt, and they were paying for 10 times the maybe the demand, and they were paying the penalty for power factor. The penalty was close to 1 CR, and this could be easily resolved by the night mode operation of the inverter, but it was not being done. And then we had to give them a solution by giving a shunt reactor, about 800 kVr shunt reactor, along with this statcom we gave, and then only the problem could be resolved. So this is what we are not utilizing the inverters. We are not maybe configuring them maybe properly. So we have to look into all those things before we jump into the you can say requirement of statcom as a magic solution. So that is what I had these a few points. As I said, we don't have to use inverters only as a maybe a dumb device. We have to see that they are used intelligently. So these are some of the points which I had noted. And as I said, I am not an expert on a power system, but I had interacted with some people. I had interacted with our clients, with some experts from overseas also. And this is what I could make out. So I will now like to understand from maybe the people from CEA or from maybe Power Grid or Grid India, City UL, if they have any thing to say, because we have been getting the, you can say, sort of the plants which are ready for integration are not being allowed unless they go for the statcom. So the situation is very critical, and the industry is suffering for that, and we have to come out with something. And if there is a justification, maybe there could be a justification, but I would like to hear from maybe experts who have studied the things in a more detailed way, who have maybe executed some plants along with the consultants, along with the developers and all, and they have a better insight. So maybe I will like to hear from some of these people only. I think Mr. Chandra Prakash, I don't know whether he's available in the meeting. Hello. Or anybody, if I can, we can just have the discussions, because it is an interactive thing, as I said, and we can have a discussion from the participants. There are people in the thing, but I'm not able to admit them. I don't know. I'm not able to admit all. So the 35, 50 people are waiting outside. I don't know. I'm not all are getting admitted at the same time. I think some people from CA, they are waiting in the waiting room, and I'm just admitting them. Okay. I don't know why they. Yes. Yes, in the meanwhile, from anybody in the audience, maybe till the CA people all join, because many of them were waiting outside in the waiting room.
Oh, no, I tried a lot, but I think there was some update required. So I just went through the update cycle and joined now.
Yes, sir.
Sorry about that.
Okay, okay. And I was writing comments from the audience only. I had briefly explained what the situation is today, because what has happened is that we have some isolations, the instability in the grid is there, instability is there, and we had a lot of isolation of RE plants. And then what we got you can say, from the agencies is that we should go for STATCOM to override these problems.
Mhm.
And these maybe the what I was talking is, if the grid is weak, if the fault levels are low, and these maybe STATCOM or inverters may not be able to cope up with the situation due to the grid issues, or maybe because of their own configuration not being up to the mark, or their maybe level may not be up to the mark. Because what we say is, other places they confirm, the inverters confirm to the SCRs of maybe up to 3 or even low. And I don't know what is happening here. That's why I wanted to hear from the people who have been involved in this process.
Usually, when there are weak grid tie inverters,
Hanji.
and as I think your observation also made a note that if it is a heavy inductive load,
Mhm.
the grid tie systems tend not to be able to cope up with heavy inductive load,
Mhm.
and you need some extra, instead of having the AC capacitors, you need substantial DC rail capacitors for coping with the instantaneous fault clearing power.
Mhm. And then that's what, if we have only a problem of a voltage adjustment, if it is only to recover the voltage, definitely the STATCOM or the inverters, they are the best devices and they can cope up with that. But suppose the problem is not with just voltage control or voltage stability. Suppose the problem is much deeper, and if the fault levels are beyond, you can say, control of the inverters. So whether we have inverter, whether we have STATCOM, as I said, the phase lock loop controllers, they are not able to detect the situation, or they are not able to correct the situation. They have to, in any case, either trip or they go into a oscillatory mode or undamped oscillations and all, and the situation is not safe. There is an isolation. That's what I was talking. As it is not a problem. The STATCOM or inverters, they can. We have unused capacity of inverters. We don't have to put additional STATCOMs for that. We can always do it with that.
देखो कहाँ बैठते हैं और उनका नंबर लेके मेरी बात कर।
And so we already have the systems available for that, and that is not a point which is disputed. We don't dispute the capability of STATCOM. We don't dispute the capability of inverters. But if the situation is beyond their reach, I'm talking of that. Here the situation seems to be beyond the reach for two reasons. One is that they are not tuned properly, and second is, they are, even if they are tuned, the situation is out of their hand. We need better, you can say, inertia. We need alternative sources of improving the inertia, grid strength. We need fault levels. We need things. Even the STATCOMs, when we have to tune them properly also. So these issues are much deeper, and we are maybe looking at very superficial level at these things. That's what I have put these questions to the audience, and I wanted to hear something from maybe Grid India, CTUIL, or maybe CA, which has made this mandatory. So there has to be a reason, there has to be a justification. When we go for a STATCOM, straight away we are jumping onto some particular solution, which may not be a right solution at the end of it. Have we done the real studies? Have we do we have the data? Do we have the, you can say, have we studied the what people are doing overseas, whether they have been facing the similar problems, or there are nothing like that? As I said, there are no issues despite much weaker grid, despite much weaker fault levels. They are able to manage the show, and then why we are not able to do it?
Narang, first thing, you are saying the fault levels are reducing.
Yes, sir.
How did you come to this conclusion? Fault line is going down.
So when the synchronous generators, the coal plants, the conventional plants are going are being phased out, it
No,
results into the
it is not being phased out.
Hmm.
Please check the figure.
Okay.
All thermal power plant, nuclear power plant, they are the base load stations. They are not reducing.
Okay.
Rather, they are increasing.
Okay.
Whatever renewable power is coming, like solar.
Yes, sir.
Solar power is available for 6 hours only.
Right, sir.
Wind power is not a constant power. Only base load stations are nuclear power and thermal power, and to some extent hydropower. How do you say fault line is going down? Transmission lines are coming up, high voltage lines are coming up, load is going up.
Sir,
Load is reducing? No.
Okay. No, I accept.
Load is not reducing.
No, you are perfectly all right, sir. They are not being phased out. Maybe the fault level may not be going down.
Rather, they have to increase the coal-fired station.
Okay.
You will see in due time, because whatever renewable power is there, solar, wind, they are not going to cope up. Because they are not continuous power, 24 hours power. They are 6 hours, 8 hours.
You are right, sir.
Wind power also depends on the wind potential. It's not a constant output.
So maybe if the
base load stations are going to cater with the load. Like you are electrifying the railways, load is going up. Charging stations are coming up for vehicle.
Sir,
so load is not going down. Power is going to go up.
Sir, you are giving a very good scenario. I accept fully. You are giving a very good scenario. It is better. In fact, then the problems should be much less. If the fault levels are not going down, if the coal plants are still being added and the grid is still strong, then why we should be talking of solutions like that? If the grid is very strong, then we have the systems available. The inverters are there to take care of the situation. The grid following things are good enough. We don't have to go for the grid following things.
Grid is going to be stabilized, because now earlier there used to be UP grid, Bengal grid. Now it is unified grid. All are connected now, interconnected. Entire India is connected in one grid. Frequency is more stable.
So we are talking of the problems at the far end, the farthest end, which are located maybe 100 kilometers, 200 kilometers away from this solar and wind energy is available in abundance only in remote locations. They are not in densely populated areas. That locations, the fault levels are low. The SCR is just 5. So it is not, we are not talking of the main grid. We are not talking of the strong locations. Strong locations, anything works. The switch capacitors will work, STATCOM will work, inverters will work, everything works there. What doesn't work is at the remote locations. The fault levels are really low. There are people who are connecting, they know they have been told to cope up with the fault levels of SCR 5 only. So the problem is there at the far end, and the 80, 70, 80 or 90% of the wind and solar is at the farthest end, at the remote end. The problems are at that node, at that locations. We have to cope up with the problem at those places. We don't have solar or this coal conventional plants near those locations. They are far, far away from them. So the problem is there.
Suppose fault level goes down, how does it affect the industry? It is good that if fault level goes down, it is good for the system.
We are talking of the renewable integration with the grid. The fault level there, the fault strength has to be very good. The grid forming system, either it's the conventional system or it is maybe battery backed inverters and all, or the STATCOM with the battery backup, it will feed the fault. If it is not able to feed, it is not capable of feeding the fault. The fault is not isolated. The situation goes to an unstable mode because there is no strength in the grid to cope up with the fault. So there the fault, these systems have to be very, very, you can say strong there. We have to have grid forming stations there. We don't have any issues at strong locations. You are right. We don't have any issues where the fault levels are good. If the problem is where the locations are far off, the SCR is very low, there we need something to clear the fault. We need the source to clear the fault.
What do you mean by SCR? SCR means?
It is a short circuit, you can say, level of the
short circuit. Okay, ratio.
Short circuit ratio.
Yeah.
So that is very low in those locations. We are talking of those locations. The solution is required for those locations. We don't need any solution in, you can say, frontline areas or main areas where everything is nice, as you said. So there is no problem there. So what I wanted is the people who have made these things mandatory, so they have to, maybe they must be having some genuine reasons. So I wanted to hear from them the reasons why they have done it.
What is mandatory rule? What is the mandatory that
Mandatory is that we have to reactive power compensation has to be done through STATCOM, 100% dynamic. The places which you are talking, it doesn't matter. Switch capacitor banks are good enough to do that, but at those locations the problems are there. And what I was talking is, even if we have STATCOM, even if we have fully dynamic, because of the grid strength, we may not be able to cope up with the situation. That was my question, and I don't know. I'm not able to get any answer for that.
There are two questions. One is for the power factor improvement. Second is the fault level. Both are independent.
No, sir, you are talking of industry. No, you are relating it to the industry. You can say thing. We can have a separate webinar for the industrial issues. They are totally different. What we are talking is renewable integration with the grid issues related to that only. We are talking related to that. So those
only grid issue.
Okay.
Grid issue. Okay.
So let us get something from the expert, because we have many experts here. So, and they have done this mandatory requirement has been made. So we wanted to hear from them why it should be there, or whether it is going to solve. Suppose today it is accepted, there is a gadget notification, everybody starts doing it, and tomorrow we land up in the same situation. So what is going to happen?
Yeah, I heard you in the beginning. You mentioned that
Yes.
the phase lock. We are talking about the phase lock loop.
Yes, sir.
And at the fault conditions,
Hanji.
the rate of change of frequency dipping, I remember the old days when we used to design the under frequency relays.
Hanji, sir.
So I could find that the rate of change of frequency at the fault conditions could be as high as 20 hertz per second.
Right.
Whether the grid tie inverters, phase lock loops are able to discriminate between the steady state phase lock loop conditions, which is about 0.5 to 0.3 to 2-3 hertz per second, and during faults it has to chase much higher speeds to be able to sustain and not get disconnected from the grid or insert instability, because it is working more like a current source.
Yes, sir. Hani, sir, you're right, sir. What is happening is, steady state condition, we have no issues. Steady state condition is perfectly okay anywhere, even it at the remote locations, farthest location, we have no problems during steady state. Anything works there. And during fault conditions at those locations, nothing works. And the reason could be that, as you said, PLL controllers, maybe if we are designing them properly and they are able to correct the situation because of the proper tuning, it is okay. But if the situation is out of their hand, they will have to trip. They have to detect the fault fast changes and they have to isolate. But if maybe that is not being detected, PLL is not detecting, they are not tripping, they are still in the system, but they are not doing anything. They are going into an oscillator mode and all. So
I can share my experience, which I had worked on uninterrupted power supplies for mainframe computers.
Yes, sir.
Where if there was a fault on the grid, we were monitoring a window of rate of change of frequency, and beyond certain tracking range, we used to disconnect with static circuit breakers the inverter system from the grid and have it only connected to batteries during that period. And then once it comes into the slope is in the tracking range, it would be locked and reconnected.
Yes.
So now, if the area to work on would be only phase lock loop and the tracking range and disconnection range.
No, phase lock loop is just one aspect of the inverter tuning I just mentioned as a point. because there are many parameters. They have to be within the power plant and within the with the inverters. They have to be properly coordinated. The settings have to be there. The time constants have to be maintained properly. And if we are doing it properly, maybe they will override certain situations which are manageable. But beyond a certain limit, they have a limit to that. After that, they will also not be of any use. They have to isolate, and that is what is happening. The phase angle changes, they isolate at that point.
Yes,
And that,
quite right.
that is what we are looking at, and whether what we are suggesting is workable or not.
Narang sir,
Yes, sir.
this is Karan Patel, sir.
Yes.
Sir, I completely agree with you that when you are mentioning that when we are dealing with a renewable energy plant integration,
Yes, sir.
definitely at the PCC, if you compare the PCC of renewable energy park, whether it's solar or wind, or when you compare it with the PCC of a thermal plant or a base load plant, there is a huge difference in the short circuit capabilities. I completely agree.
Yes.
Now that CEA has mandated that the RE complex needs to take care of the fault, whether it's high voltage ride through or low voltage ride through. Do we have any data, or can we ask CEA to provide the developers some data? What kind of faults are we talking about? Because since you mentioned that that a STATCOM could be a potential solution, but how are we going to tune the STATCOM? Are we going to tune the STATCOM for voltage stability? If yes, what levels of voltage stability? And if STATCOM is going to do the dynamic reactive power compensation, then what levels of reactive power compensation? Can we ask a CEA certain kind of data which can get us some clarity?
And definitely, that's what the webinar purpose was today, to have an interaction with the CA and the agencies who are coordinating with CA for the mandatory requirement CA has made on the advice of Grid India and CTUIL. And we thought that we'll have an interaction and maybe we'll throw these questions to them. I said I have not prepared any presentation in any particular order. I just noted some points and threw it open to the audience, and to particularly to these agencies only, to get an idea how the things have to be done. And as you said, the STATCOM, if it is only a problem of voltage detection, voltage control, so there is no problem. STATCOM can be configured to have the LVRT, HVRT condition if it is only a voltage requirement. But if it is a problem much deeper than the voltage, if the system is unstable and it is going out of synchronization in any case, so then what STATCOM is going to do? We have
Nara, I'm not clear still. What is the difference between the normal power plant, thermal power plant, and renewable plant as far as grid connect integration is concerned?
The grid, renewable plants, they don't have any inertia. They are grid following systems. The conventional plants are grid forming stations. They have the they provide the fault capacity, fault handling capacity, strength to the grid. They provide the inertia to the grid, and they are able. We are able to ride through the maybe faults easily, and we are able to save the situation. The grid is not isolated. The grid remains functional because of the inertia of the system. And
the fault levels vary a lot.
During fault
levels are drastically are significantly different than the conventional power plants at PCC.
Yes, sir. So they have a different dynamics. That's why as we go further into the penetration, the integration of the more and more renewable energy, we have to have the systems which are similar to the conventional. We have to have the grid forming systems added. We have to configure with these inverters with the batteries and put them in a grid forming mode. And we have to have maybe synchronous condensers more and more, just for only the grid strength. Because otherwise, it is not going to work. Just putting a STATCOM without any grid forming, you can say, thing built into that, it is not going to solve the problem.
Narang sir.
Yes, sir.
Yeah, Virendra here. Sir,
Yes.
I have a question.
Yes.
So, in generally, point of interconnection is in government substation, whether it is CTU or STU.
Yes.
Okay, the renewable energy plants are far away. Let
Mhm.
us say WTG output is LT,
Mhm.
inverter output is also LT. In
Right.
between, a 33 kV transformation, step up, again EHV, and again the transmission line, then PU point of interconnection will be arrived at.
Right.
So we need to control the grid at point of interconnection, but we do not get any real-time data of the point of interconnection. What is the real-time frequency
Okay.
and what is the real-time voltage and everything. And also when there is a dip in the frequency, as sir mentioned in
Mhm.
the
Okay.
earlier conversation, how a inverter will get the data of the point of
Right.
interconnection at LT output.
You are absolutely right, sir. You have actually.
And another question, sir.
You
What is the response time? 5 milliseconds or 10 milliseconds or 20 milliseconds? Whether the WTGs and the inverters are capable to support the grid, I mean, so the voltage right through within the 5 or 10 milliseconds at the
Yes.
point of interconnection, it is 100 kilometers away from the generator.
These capabilities are there. Inverters have all the capabilities. And what you said is
Response
that
time, sir. Response time.
response time also is there. Response time also is not an issue. The problem is that you said that you don't have the data available. Suppose you don't have a
Right.
coordination between the inverters and between the power plant or between the system. How you are
Right.
going to coordinate? Suppose the data itself is not there.
The requirements are not clear.
And CTU case, recently they have formed some guidelines. There are some power quality meters to be installed at the point of interconnection, that is at the PGCL substation. But in the STU level, there is no clarity because STU
And
grid controllers.
So one more thing you said is that there are power plant controller PPCs are there, and what happens is during a fault conditions these PPCs freeze. They are not available for any control. PPCs are only for a steady state control.
Absolutely.
During fault level, inverters are left on their own. They have to manage with their individual controls only, the default controls, whatever they are having
So
within
they
that.
will manage at their output only, LT output only. They cannot manage at the point of interconnection unless it is not getting the closed loop communication.
Yes, that closed loop and all has to be there. But in fact, you are putting the question to me as.
No, it's not to you. It's not to you. It's a complete to forum.
No, I'm myself putting questions to the experts who are there in this field, who have made this thing mandatory and who understand better, who know better, who have handled more systems. In
My
fact,
main question is now
along with you for these questions to the people who are from these agencies.
Sir, second question is, if recently we have been received a letter from the CA that dynamic reactive power support to be there for, okay, we are okay to ready to give. For example, I am putting SVGs. How the SVG will talk to the point of interconnection? How it will come to know the point of interconnection? The voltage is getting dip. I mean to say the frequency is getting dip.
So you are absolutely right. SVG or STATCOM will only work in a steady state condition under the present scenario. If you don't have those loops and things, steady state, even capacitors will work. So why to have a STATCOM? Well, that is what I am questioning these people, that STATCOM will work for maybe it can give the dynamic control, that is okay. But during steady state only it is working. During a fault condition, if the fault is beyond its capability, it is not going to do anything.
Right.
And another question, sir, if we are using the generators like WTG's inverters to support the grid, we will lose, as a developer, we will lose the active energy. So we will not get paid for any reactive support.
You don't get paid for reactive support, but it is your responsibility to provide reactive support, proportionate reactive support to your installed, you can say, capacity.
So my capex will go like anything. The inverters for 100 megawatt, I have to design for 110 megawatt.
Capex definitely will go up, and it is a requirement of the system today. The power system needs it. You cannot. There have been problems in the past, last maybe 10-15 years, when this solar started coming, solar and wind. There was no implementation of any regulation to have the reactive power support within these renewable plants. Nobody was putting anything. They were just managing with only active energy, no reactive support at all. And although there were, you can say, guidelines were there in all the utilities. Every utility had the guideline that reactive support is required to the extent of maybe 20%. Karnataka was saying 40% they say in Australia and all. Now CA has said 33%. This should have been there right from the beginning. I wrote an article about 4-5 years back that why we are not asking these people to put reactive support. Your capex has to go up. You need to provide, if you have to generate the energy and you have to supply to the grid, you are responsible for providing reactive power as well. It is your responsibility to do that. You can't escape that responsibility. And now the question is whether we don't, earlier we did not even ask for the passive banks, the switched banks. Now we are straight away asking for the StatCom. So this is the anomaly I am talking about.
Because like solar power, they cannot generate reactive power.
They cannot generate reactive power.
Cannot generate.
Like
wind power, probably they can generate because they have got the
solar inverters. They operate at maybe 80% of the capacity. They never operate at full capacity. They have reserve reactive power. They can be configured to supply reactive power. As I said, suppose you are operating at 0.8 D loop, and then you have about out of almost 50% capacity of the inverter is available for reactive power, and it is being supplied. The inverters are supplying reactive power, and they are capable of supplying reactive power.
Okay.
And it is being done also. And what I was saying is that we when we have the inverters which are already capable, which have the reserve capacity, the unused capacity, if we are not using it, why we are jumping onto the StatComs additionally, increasing the capex unnecessary?
You see, reactive power, it is decided by the user, not by the generating plant. Generating plant should have the capability. But it doesn't necessarily mean that they will supply reactive power, because reactive power demand is by
the voltage control loop is there, that they have to be part of the system. Just like other plants, conventional plants, they have also to contribute to the reactive power as per the grid requirements.
Correct.
And it is okay. It's, some people maybe you can say compensating, and some may not be. Recently, we had a case. The plant is ready. It has maybe 40 MVR or so reactive power capacity installed, but they are not able to connect because there is a close by 400 kV substation. They have about maybe 200 MVR or 300 MVR permanently connected in a fixed mode. The voltage is already from instead of 220, it is always 225 plus. So they are not able to even connect it. So one plant can overcompensate and the other remains without compensation. So they have to be equally compensating for the system. And they are required to do that. It is the responsibility of each plant to provide the proportionate reactive power as per their capacity.
Yeah. If I can add one more point, normally the grid tie inverters, normally which are there in Europe, they follow the similar mandate which has been given recently by CEA, which is like the inverters need to maintain the reactive power between 0.95 lagging and 0.95 leading. So a standard inverter would definitely be supplying in a steady state this amount of reactive power for sure.
Right. In both in steady state as well as you can say fault state, these are available, and we have to have dynamic power. Dynamic power is available from the inverters itself, and we are not using that power, and we are not even using the simple night mode also. We are doing nothing, and we are asking them to go for additionally StatCom. So the existing capacity is unutilized, and the additional is being asked for. So that was
the. Yeah, but one more point. I don't know what really the case is. I've come across the cases where I have seen the power electronics inverters, they are not even rated properly so that they can supply this amount of reactive power. For example, let's say that there is 100 kilowatt solar power. Then you need let's say 110 or 115 kVA of inverter, because 100 kilowatt of solar power maybe can deliver maximum 80 kilowatt of active power, and 20 will be needed for reactive power. So even in many cases there are also undersizing of the inverters, which can cause the issues to the RE park developers.
You're right. In India, what we have cut-to-cut sizing only. 100 megawatt means we have 100 megawatt inverters only, but still they are able to supply, maybe still they run at 0.8 only.
But then there is a loss to power RE developers because they are not able to evacuate the planned amount of capacity.
After using whatever best they have, they never operate beyond maybe 80% or something. So they have the reserve power available. It is not that you have to oversize the inverters to maybe 40%. You have to see practically how much you can supply with the, you can say, normal operations of the system. And that is possible. And you have the capacity in inverters. Only thing is, as you said, we are not configuring those things. We have to configure and we have to get this capacity out of these inverters. And this is a dynamic capacity, very wonderful capacity, which we are leaving it unutilized. And just because we are not tuning, we are not configuring the inverters. As simple as code, we are not doing it even. And I checked up in Australia, all inverters by default are, you can say, configured for night mode there. And here we give special systems to cope up with that. Yes, sir. So if we are getting
from my perspective, from my perspective, the way I see the mandates which are given by CEA, it would be more interesting to see, like they have mentioned 28 incidents since January 2022. Now it would be interesting to see the data, what kind of incidents have occurred, which have caused the loss, which have caused the trippings of the solar parks.
Now, interestingly, I was just talking to some people. They said that there was one installation with a STATCOM also available, and it did not cope up with the situation during that fault. LVRT, HVRT, it was not able to do anything. So that's what the question is today. We are asking something which is a capital investment, and we are overlooking the simple only the you can say configuration, which doesn't require except some expertise of the people. So if the problem can be solved with that, we are not doing that, and we are going straight away to a capital investment. So why it should be made mandatory? That is the basic question today.
Right. Yeah, because even if, let's say, if we connect a STATCOM, if we size a STATCOM, how do we tune it? What are the requirements to tune the STATCOM? What amount of control voltage stability? What amount of reactive power compensation? So all those things needs to be clear. Otherwise, even STATCOM installing STATCOM, as you rightly said, will not help.
So STATCOM installation may not at all help because it will be configured with the PPC. And during fault condition, PPC is out of service, it freezes. So whatever tuning you do for the STATCOM is always configured to supply reactive power instantly. It can cope up with that during steady state condition. But during fault condition, it is not available. The PPC itself is not available with which it is configured.
Yeah.
See, I have been listening to all the. I am not very familiar with the HT connectivity. I have worked with all inverter systems right up to 2000 kVA for mainly uninterrupted power supply. And in that connection, always there used to be a problem of feeding the reactive load because basically you are working from a DC source which can only supply active power. The reactive power is a circulating current between the DC source and the load.
Yes.
You must have an energy source across the solar system, PV panels, to support the reverse conducting currents from the AC grid. And unless you have that energy storage element, at least to the extent of what is required to feed the fault. And if suppose your fault clearing, the entire fault clearing process requires 2 minutes, 3 minutes, or 5 minutes, you need DC link capacitors on the across the solar panels for stabilizing your grid. Without that, you cannot handle the reactive power. You have to handle reactive power. Inverters are capable of handling reactive power, but they will take power during the half cycle, quarter cycle, and they will absorb power, reverse power into the solar panels cannot absorb that reactive power. So negative power coming in, which is out of phase. So you are tying up with the grid, and you want the reverse current to be handled on the DC bus. SATCOMs are connected to the output on the AC side. They will not do anything. They will work only if it is a tuned circuit with some reactor across it to be able to support few milliseconds or say 300, 500 milliseconds of energy. But if you want to provide minutes until your circuit breakers open or whatever fault is to be cleared, then the entire capacity of what is the fault level will have to be stored into the DC side. That is the only way in which you will take care of the phase lock loops. Even if they are able to track the grid, they will not be able to handle the reactive power coming back.
So that's what we are asking. The STATCOMs are not capable of feeding the fault in a weak grid condition, and they are not able to clear the fault in time.
They will not.
They are not able to clear. They are not able to take this burden.
No, they will not. You will need some energy storage.
We need a synchronous sensor, or we need
the solar panel.
Yes, yes. These are great following system. The STATCOM is also a good following system. It's not a great forming system. It will not be able to clear the fault. The fault will remain within the system, and by the time maybe the system will go out of synchronism.
Yeah. See, in Australia, Elon Musk just supplied a power wall of some megawatt hour capacity. Now, and that is where I think they are connecting the for only feeding the peak loads. And that is where they are also able to provide the peak loads during night time. So without the DC source across the solar system, PV panels, you will not be able to handle the inductive power at all, reactive power at all. Control systems are available which can track right up to 20 hertz per second. The normal tracking range will not be beyond say 47 to 53 hertz. And anything that goes beyond this range, it has to go out of sync. And if you don't want it to go out of sync, you will have to track it right up to, if you say even if suppose the grid shuts down at say 10 hertz per second, then you have to cover that entire zone of energy up to 10 hertz per second. At what rate does it sink to that level? And that much energy has to be stored across the solar system.
Yes, sir, you are giving good inputs. Only thing is, we wanted to hear something from the, you can say, experts also who have been handling. So far, I'm not getting any, you can say, opinion or inputs from that. Or maybe we'll need a special meeting for that exclusively, because maybe they are not opening out in the common forum, it seems.
Yeah.
But in the panel, we can discuss anything further on that, because these RE developers, they are facing issues. They are being asked to have capital investment by way of STATCOM, which seems not capable of solving the basic issue for which it is being asked for. So that's why we'll maybe if we have some RE developers, maybe they can also give their views on that.
Sure, I think what has happened, perhaps all these power electronics people have graduated from the LV side, and the power, the transmission and grid type people working on the 33 kV and that level, they are not used to this level of interaction between reactive power into the how to handle into battery. But I have also seen batteries conking up with handling the inductive power, because they can also not absorb the 100 cycles and 300 cycles ripple currents into the batteries.
The batteries, as I said, alone with the inverters will not solve the problem. They also will become a grid following batteries only. What we need is we have to configure them for the grid forming mode, and then they can give some virtual inertia. Otherwise, they are also not capable of giving that.
Yeah, see, virtual inertia is what ultimately the rotating machines have got that half MV square total inertia is available. That inertia is not available in a static system.
Yes.
That inertia is available only in the form of either battery or a battery and capacitor combination.
Yes.
Without which and that is really time dependent. That if you have to handle few minutes or few seconds for clearing faults, so that much is the stored energy necessarily required with the grid tie inverter.
Yes. So, any opinion from RE developers?
So Virendra here again.
Yes.
So instead of seeking the reactive power support from renewable energy plants, why can't a grid controller keep such kind of the equipment in their government substations? So they are issuing the connectivity for each and every plant, 300 megawatt, 200 or 100 megawatt.
Yes.
So when they are carrying out the integration load flow studies or whatever the system studies such as PSSC, PSCAD, they could find the reactive power support considering the future expansion of the grid and the response time. They can develop the such kind of equipment in their substation, in their infrastructure that can be paid by the developers.
That is okay. It has to be available in the system. It doesn't matter whether you have it within the your RE complex or it is adjoining maybe system complex. It is one and the same thing. But
I mean to say, sir, point of interconnection and the reactive power support equipment should be nearby.
That maybe they can. You are having one opinion you have put out that you can share the cost and the same can be installed at their premises. This is also possible. There is no problem in that.
This is the fair solution, I believe.
I don't find any issues in that. But suppose you have some RE plant, you have a solar or a wind generation plant, and you also have additionally some your own in-house loads also.
Those are very static loads, sir. Those are insignificant.
Not in-house, not the loads which are required for your operation. The loads means you have a plant also connected along with that. You also have an industry along with that, and you are feeding that also from your solar. So there, if you have the reactive power at your control in your hand, you will be able to utilize it for yourself. You don't have to depend on grid for that.
Actually, spoke about the captive plants, sir. But in captive plants, this kind of the complex issues will not be there. I'm talking about the CTU EHV connected projects.
In the case where you have exclusively only for generation, you don't have any consumption of your own.
Absolutely.
Then it is okay. Then there should not be any issue. If you put your system with the grid, you just pay them and they install it. In any case, as I said, one example, we have a client who is having maybe issues. He has installed, but he doesn't need because the adjoining system has overcapacity permanently connected reactive power. So instead of asking these people, because in fact the solutions have to be project specific. They cannot be, you can say, blanket solution for everything. What has been done here is they have given a blanket solution for all situations, all locations, whether the size is big or small, plant size, or whether the grid is weak or grid is strong, irrespective of anything, they say that you go for STATCOM. So that is what is something which is not understandable.
Right, sir, right.
So in fact, blanket solution don't work in any, you can say, situation. It is not only in this particular case, but it has to be looked specifically. For each and every situation, there has to be a proper solution. And as I said, maybe we are not getting any feedback or opinion from the maybe agencies involved who, although they are available in the system, I will be very happy if they just respond and if they just say something from their side. The CA, in fact, the people who have organized, they also, I would like to hear something from them, at least not on the subject, but about the webinar or about the maybe future course of action, how they see the things to be taken up in future. How do we intend to go further, maybe deeper? This may not be a right forum to discuss such sensitive issues for these agencies, I fully understand. But what can be done? How can we take it further from this level? At least we can have some roadmap how we are going to tackle this situation. Because we have many people from CA here already, and I'm not aware about the other agencies, Grid India and CTUIL. They also must be there because they were also uh, uh, given invitations, and the consent was there to attend. We have still maybe 5 minutes or so left, and if any opinion is there, it will be welcome. I think Mr. Jitendra Meena, you wanted to say something, but or we may be having some consultants also in the panel. They can throw also some light on the subject. And I think if there is no further point coming from any participant, maybe we can go towards closing the session. And I thank Central Electricity Authority for organizing and for attending in a large number. Many people have attended. At least the our whatever we wanted to say or whatever points other panel members also had, participants, they have been put through, and we have at least conveyed certain points. We have raised certain issues. Maybe we'll put it further in a formal way also if required, if they need. And we will like that something should be taken further from here, and let us keep this discussion on till everybody has a satisfactory solution. The developers, particularly, they are at the receiving end, and they are not able to understand what to do.
Sir, can we be able to get the summary of this call in the LinkedIn or somewhere? So
Yes.
what the discussions were done?
What I will do is I'll put the recording on LinkedIn.
Fine.
So it will be available to the agencies also. If they have not, maybe some of them have not attended, they will be able to hear it again. And we don't we are not asking them to provide any solutions right away. We are just asking that let us have a wider discussion. We are not competent to take any decisions. We are just here to give our opinion, and everybody is those who have participated, they have also given their opinion, and let us take it that way only. And ultimately the agency CA, they have to finally decide. And I had a personal meeting also with CA as chairman of EMA Power Quality Division. I had met, and I was along with the other you can say solution providers, ABB, and some Stream is there, and there is Universal and all. We all went there as a one unit, and we expressed our opinion same way what we have told today. Same thing was conveyed to them, and we had a very positive response. They were very receptive. They were understanding, and they also felt that things need to be discussed in a wider way. And the proposal for this meeting came from there only, CA themselves suggested that let us have a wider participation and let us find out if we can get some maybe solution which is better or which is more maybe a lasting solution and acceptable solution to everyone. So that is how this meeting was organized. And in fact, recently I have written one article also. Maybe I'll share that article also on the LinkedIn as well as maybe on YouTube and all. And these are only just, as I said in the beginning, I am not an expert on the power system. I just have been working with these things. I have worked maybe initially during a graduate engineering training stage. I was there in a super thermal station, 600 megawatt, navally lignite. So I have just learned something from there only during just after passing out. So otherwise, besides that, I have never worked in a power system. Otherwise, we are giving solutions for this renewable. We are giving solutions to industries. So we know, we understand something about this operations of the power system, the grid integration, and all those things. And even when I was in IOC, there also we had our own 16 megawatt captive power plant. So certain things I understand, but they are all maybe limited knowledge. So this is not something which I fully understand. So whatever the understanding I have put it in the article as well as I had conveyed during the meeting. And today also we discussed, it was also very good. And let us take it forward till we have some solution, because still the sword is hanging. The mandatory requirement for STATCOM still exists for all the RE developers. And there is not a single STATCOM so far planned or taken or decided by anybody. And the one major problem is we have absolutely zero capacity of making 33 kV STATCOM. The STATCOMs have to be connected because our integration is taking place at 33 kV. We have to have 33 kV STATCOM, and that has to be imported. We can import it from Europe, we can import it from China. Ultimately, if the choice is left, it will come from the cheapest source, it will come from China only. And again, we should not land up in the same situation as we have with the inverters. Maybe we have inverters, but we don't have them maybe properly tuned. Could be the issues are that we are not modeling properly, we are not tuning properly, we are not retuning after a fault also maybe. So those things could be the major issue. And giving just a blanket solution without much insight into that may not solve the problem. So with this, I think I'll close the session. And if there is anything somebody wants to add, he can add. Otherwise, we will close.
Excuse me, sir. Thank you very much.
Thank you, sir. Thank you, everyone, for participating.
Thank you, Narang sir, for attending, for organizing this webinar.
Okay. Thank you, sir. Thank you.
Thank you very much, sir. Very informative.
Thank you, sir.